Hello guys, as you all know I am Navya Sri HS, pursuing second year CS Engineering at Sri Venkateshwara College of Engineering with the USN 1VE23 CS 112. Today we are going to discuss the topic in the subject of Digital Design and Computer Organization with the subject code BCS 302. Today's topic is Ternary Encoder. Introduction about the given topic. A ternary encoder is a digital circuit that encodes data from three possible states, often represented as -1, 0 and 1, into a coded output. Unlike binary system that uses two states 0 and 1, ternary encoders work with three, allowing for denser information storage and processing. In a DDCO context, implementing a ternary encoder requires understanding ternary logic, circuit design principles, and the use of hardware description languages like Verilog for simulation and hardware realization. Next, we are going to discuss about the basic concept of ternary logic. A ternary logic system, also known as three-valued logic, uses three possible logic levels instead of two, typically denoted as -1, 0 and 1 or 0 or 1 and 2. This logic is analogous to binary logic but allows for more unanswered representation of states, which can be beneficial for certain computational problems. A single ternary digit can represent three possible states, allowing for greater encoding capacity compared to binary systems, where each bit only represents two states. For example, a binary bit can represent two values 0 or 1. A ternary bit can represent three values -0, -1 or 1. Thus, for the same number of threads, a ternary system can represent more information than a binary system. Next, we are going to discuss about the applications of DDCO. In a DDCO setting, and understanding and implementing a ternary encoder serves to teach students about multi-valued logic system, advanced logic design, and encoding mechanisms. Implementing ternary logic in hardware, typically through Verilog or similar hardware description languages, requires creating a design that can recognize, process, and output the corresponding ternary values. Now we are going to discuss about how ternary encoder works. A ternary encoder converts a set of inputs where each input can take one of three values into a coded output that represents this input in a more compact form. This process is analogous to binary encoding but with a wider range of input values to encode. For example, in a 3 to 2 ternary encoder, the inputs can be a combination of three values -1, 0, 1, and the output will be a 2-bit code that represents the corresponding input. Here is the truth table of ternary encoding. Next, Verilog implementation of ternary encoder. In DDCO, Verilog is commonly used to design and simulate encoders. Below is an example of a simple ternary encoder written in Verilog. Here we can see the example using a ternary encoder how Verilog works. This example shows how different input combinations are mapped into binary outputs. Next, we are going to discuss about advantages of ternary encoders. Higher data density. A ternary system can encode more information per unit compared to binary system. For example, one ternary bit can represent three different states, whereas a binary bit can only represent two. Next, potential for lower power consumption in theory. Ternary systems may reduce the number of transactions between states, lowering power consumption in certain applications. Simpler circular gates, some arithmetic and logic operations can be simplified using ternary systems. For example, decision making can be involves more than two distinct contexts, can be handled more naturally with ternary logic. Next, we are discussing about challenges and limitations by using the ternary encoder. Increased circuit complexity. Although ternary systems can be efficient in theory, designing hardware that can be reliably distinguish between three states is more complex than designing binary circuits. Ternary systems require more spontaneous control, especially to maintain signal integrity and manage power levels. Interfacing with binary system, most modern digital systems are based on binary logic. Converting between binary and ternary system requires additional circuitry, which may introduce inefficiencies or slow down operations. Next, error detection and correction. Using ternary encoder, how we detect errors and how we correct them, we are going to discuss about it. Ternary system introduce additional challenges in detecting and correcting errors, while binary systems have well-established methods for error detection. Example, parity bits. These methods need to be adopted or re-engineered for ternary systems. Ternary encoders in advanced applications. Here we are going to discuss about how ternary encoders are worked in advanced applications. Ternary encoding systems are often discussed in the context of quantum computing and high-efficiency communication. Quantum computing, in the quantum world, systems can take on more than just two states. Qubits, which are the quantum analog of bits, can represent quantum superposition of three different states. Ternary encoding schemes may therefore have application in quantum information processing, where they can provide more natural framework or certain type of quantum algorithms. Communication systems. In communication theory, multi-level signaling schemes including ternary and high-order systems are used to maximize the data through input within a limited bandwidth. Ternary encoders can be used to implement these schemes efficiently. Now we are at the end of the concept, giving conclusion to the ternary encoders. Ternary encoders represent an important expansion of traditional binary encoding techniques, offering advantages in terms of data density, power efficiency, and circuit design flexibility. In a DDCO context, they provide a valuable exercise in advanced logic design and hardware description. Using languages like Verilog, despite the increased circuit complexity and challenges associated with interfacing with binary systems, ternary encoding has potential applications in quantum computing and communication systems and digital design. That's all about the concept. Thank you for watching my video. Please do like and share the video.